Alrighty, so today we're working on my 1989 Ranger, and so if you come over here for our MAP sensor, you would have expected a voltage reading just with the age of this truck, but it actually is a frequency that we're going to be looking at. So here's what we got, because when we tested voltage, we saw 2.5 volts, which would indicate that we were seeing a wave go up and down, and the meter wasn't fast enough. So now we got to switch to frequency. So here's what we got. So at 21 inches of mercury, we should see about 102 hertz, and at 0 inches of mercury, we should see about 159. So let's go over to the truck and let's take a look at what we got. We're just about 20 inches of mercury right now, idling. And we come over here, we got 108 hertz, 104, bouncing around there, which is pretty good. That's pretty spot on. So now at wide open throttle, you'll see it adjust. Gauge though. Okay, so I'm back on the 89 Ranger. I got out the scan tool, got her all plugged in and figured out. I did a quick cylinder power balance test, engine running, key on, and here's what codes came up. Number 21, which is an ECT higher or lower than expected, which is fine because the engine's been off, so the temperature's not right. I've got a 42, lack of HO2s, switches, rich in bank 1. I got a 72, insufficient map and MAF change dynamic test, so that's something I did wrong. And 73, insufficient TP change and dynamic test. That's also, like, I didn't whack the throttle hard enough, I think. Alright, got the 2011 Chevy Express. I'm going to show you here. We've got the red, which is our MAF signal, and you can see it's a frequency. If you look real close down here, we're getting about an average of 2.7 kilohertz, about 3 kilohertz if you want to round it. And then we got our blue line here is our MAP sensor, and that's at about 1.5 volts at idle. And then we have this green line here that is just our MAF signal, which is a 12 volt signal. Alright, so now Chase is going to get in there. We're going to slowly rev the truck up. As you saw, our kilohertz went up, our frequency increased, and our voltage changed it with pressure. So now we're going to do wide open throttle. One more time. Perfect. You saw our MAP sensor shot up in voltage, and our frequency increased. Alright, now we're going to unplug 3 cylinders, one at a time. We're going to watch what happens here. Now I'm to 2. That's 3?
That's 3.
So see, the engine pretty much took care of it.
Yeah, kind of unfazed.
And you know, it adjusted for that. Like we discussed in class about cylinder deactivation, it still takes the certain amount of air
As you can see,
to make up for the dead weight.
Over here. It's running rough, most definitely. But it's taking care of the pressure readings.
Alright, go ahead and plug it in, Hunter. Plug them in.
Plug them in.
So here we're going to watch our readings. It's one plugged in.
Oh, so you can see that the voltage jumped up real quick. Went up to 1.8.
2 plugged in.
And now it's dropping down in voltage as well as hertz.
That's 3 plugged in.
Alright, there you go. Back at idle, all cleaned out. Almost back to idle.
Now it's at idle.
Yeah. Okay.
Alright, on that 2011 Chevy Express van, here is our mass airflow MAF sensor diagram. And then on our map, we had that over here. We had that. Alright, in the cab now, because that's the easiest way to get to the MAP sensor. We got the doghouse pulled back. And we got our engine. And right up in there. Let's see if I can get the phone in there. That guy right there is our MAP sensor. See the wire coming out of it for testing? That's it. And here under the hood, what little a hood is, we got the MAP sensor just dangling right in here. It's got the intake air temperature on it. We got our pin A and B, signal, and 12 volt reference.
Step limiter, 1 mile.
Oh. That's the outro.